Hello everyone. Okay, so this is a review of test 1 for market process and world economy summer 2 2013. So let me get my image out of here and we can begin. So this is what you're looking at is the grade sheet for the first problem, and you're given those supply and demand equations there, and you're first asked to calculate the equilibrium price, this thing right here. And the way you find the equilibrium price is you just set the quantity demanded equal to the quantity supplied. So you should have a setup of 1800 minus 6px equals 2px plus 260. And when you solve for px, you should get that answer 192.5. Then to find the equilibrium quantity, you just plug the equilibrium price of 192.5 into either the demand equation right there or the supply equation right there. In fact, if you're nervous, you should do it twice because you should get the same answer both times of 645. Now, price elasticity of demand at equilibrium is a little harder. You need the formula for price elasticity, which is 1 over the slope times P over Q. So the P and Q values are really easy because they're just given from the equilibrium price and quantity. Here they are. But 1 over the slope is kind of hard. And you will find that the slope of the demand curve is minus 1/6, that is minus 1 over 6, and then 1 over the slope would be minus 6, or its inverse. So price elasticity of demand will work out to be minus 6 times 192.5 divided by 645. Now, for arc elasticity, that's number 5 here, you need that long convoluted formula Q2 minus Q1 over Q2 plus Q1 all over P2 minus P1 over P2 plus P1. And then you're given these two values for P of 250 and 200, and you have to calculate the values of Q that go with those, and I've done that here. Q is 300 when P is 250, and Q is 600 when P is 200. Then you just plug in the formula. You might can follow my little work over here. It's kind of hard to see, but you should get excuse me, you should get an arc elasticity value of minus 3. Then suppose the government set a price floor at 200. So if the government sets a price floor at 200, that would be binding because the market's trying to get the price down to 192.5. You got a floor at 200. It can't move. So it would be binding, and there would be a surplus because this would be the quantity supplied and this would be the quantity demanded over here, which would give you a surplus of 60. Now if you set a price ceiling at 200, that would be non-binding because the market's trying to get the price to 192.5, and the price can be below the ceiling, so it would be non-binding. Number 10 asks, how much good X would people want if the government provided this product for free? And you find that by just extending the demand curve down to where the price is 0, which would be over here, where the price is 0. And the way to do it algebraically is you just set the price equal to 0 in the demand equation, and you get the quantity demanded of X is equal to 1800. Alright, so that was problem number 1. By the way, they're worth 2 points each. When you look at your test, you can see little marks I'm making, and then you'll see a number with a circle around it, which is the total number of points off for question number 1. Alright, so let's go to question 2. This is a similar problem, except now you have a tax equation. So the equilibrium price before the tax and equilibrium quantity before the tax is found the same way you did it in problem number 1. You just use these two equations right here. And you can see my work down here. The equilibrium price was 225 and the equilibrium quantity was 1150. Then after the tax, you use the original demand curve, but now you use this new supply curve, this one down here, supply curve after the tax, and you get the price consumers would pay of 240 and total sales would be 1120. So the price producers get is kind of hard to find. That's the only thing really that's hard. And the way you do it is, since you know the equilibrium quantity is 1120, you're looking for this dot right here, this dot, because that would be what's left over for the producers after the consumers pay this 240, and then the producer pays the tax, which is this distance right here. The producer's left with that. And the way you find it is you just take that 1120, which is an output, and you stick it into this supply equation which describes that line. So put that 1120 right in there, solve for P, and you should get that number right there. Then it's really easy to figure out what the unit tax was, because it's just the difference in the two prices, which would be $20. And the tax revenue generated would just be $20 for every unit they sold, and they sold 1,120 units. This one down here is a little harder because it's a kind of a thought question. Imagine the tax were doubled, would the tax revenue generated also double? At first it seems like maybe it would, since the tax instead of being $20 would be $40. But what you have to realize is when the tax goes up, the unit sales goes down. And so no, the tax revenue generated wouldn't double. In fact, you could think of it like this. Imagine the tax per unit was $2 million. They wouldn't make a ton of money. In fact, they wouldn't make any money because nobody would buy any. Okay, so those were also worth 2 points each. You'll see my little numbers, and a bigger number with a circle around it is your total points off for that page. Here's the supply and demand with graphs. So this was all about this unbelievable new technology that's kind of emerged in the last 2 or 3 years that was really not anticipated very well before that. And U.S. oil production the supply curve has increased, which is driven down the price would be here. So it would be here are your answers down here. By the way, some of you still don't understand supply and demand very well. When you're moving from one equilibrium to another, the quantity demanded and the quantity supplied will always move in the same direction. So in the first one, the supply curve shifted to the right from new technology. In the second one, oil imported in the U.S. would shift down to the left. It would decrease because they are imports, and now domestic oil is cheaper. In the third one, what will happen in the market for solar and wind energy? Well, this is a substitute for oil, and so if oil gets cheaper, then the demand curve for those things would fall. And in the fourth one, what will happen in the market for big cars? Well, cheap gas is a thing that is related to the demand curve for big cars. They're complementary. So if gas gets cheaper, the demand curve for big cars would shift to the right. So those were worth 4 points each, I think is how I graded them. Yeah. You'll see little points off and then a number with a big circle around it. Alright, so here we go. Problem number 4 was short answer. You can find all these in the book. Most of them are in chapters 1 and 2. In fact, Adam Smith was the very first thing on the first page of chapter 1. There was a big box about him. Income elasticity is in chapter 20. You can just look these things up. This one here was a video, the supply and demand video number 1. Alright, they were 4 points each. And then Roman numeral 5, this is the production possibilities curve. So first you need to draw a production possibilities curve. That's this one on the inside here. Second thing you needed to do was identify a good production point for people who prefer about twice as much good A as good B. So that would be over here at point 2, because you want to have about twice as much A as B. If I gave you this very same problem on your final exam and I told you that people preferred equal amounts of A and B, it would be up here somewhere at about 45 degrees. If I told you that they preferred 10 times as much good B as good A, they'd be way over here someplace with lots of B and hardly any A. Alright, so then it asks, indicate how the production possibilities curve would move if there were a new technology that only helped in the production of good A. Well, obviously this point over here wouldn't move because that's exclusively production of good B, but the production of good A would shift out this way, so you get a production possibilities curve that has this kind of weird shape. It has this point in common with the original, but then it would bow out like this. And then this is a really interesting question. Would it be possible to use this new technology that really only helps in the production of good A to increase production of good B? And the answer is yeah, you could, because you think about it, if you were at point 2, you could move up there and get more of good B and the same amount of good A as before. It seems a bit odd, but what's really happening there is that because of this new technology, you need less resources to produce good A, and so you could just move those resources into the production of good B. Alright, so I think, oh yeah, there was one more. Here's Roman numeral 6. This is about the relationship between the demand curve and total revenue. So I made up this weird thing about nowhere state university increases its tuition. Will this necessarily raise total revenue for them? And well, no, it won't necessarily, because total revenue is related to the demand curve as follows. You can find this in chapter 20. Remember, the top part of the demand curve is elastic, the bottom part is inelastic, and total revenue starts here at 0, 0, rises up, maxes out at the dead square middle of the demand curve, and then falls back to 0 over here. So, if Nowhere State University is located in the elastic part of their demand curve and they were to raise their tuition even higher, total revenue would go down. On the other hand, if they were in the inelastic part and they raised their tuition, say up to here, total revenue would go up. Part 2 is about calculating some arc elasticities, and here's my work for those. And you can just kind of follow my work if you want. And then point elasticity, here's the formula, 1 over the slope times P over Q, and I just worked it out. So that's the answer key for test 1. And again, don't be confused by the little marks that you see. They're little tiny marks, really for me, that help me keep track of what's correct and what's incorrect. And then you will see a number with a circle around it, which is the total number of points that you lost on that particular question. Then you could take all those numbers with the circles around them, add them all up, subtract it from 100, and that should be your grade. Alright, good luck.